Okay, today's lesson is on finding intervals for increasing, decreasing, and positive, negative, and finding x-intercepts and y-intercepts. And I've written out a document that talks about the steps to finding increasing, decreasing intervals and positive, negative intervals with examples. And I'm going to start by using those to explain them. And then we're going to move on to the other notes and examples that are going to help with the homework. And so these look kind of intimidating because there's a bunch of steps. But it's just kind of necessary if you're trying to explain it on paper. But hopefully by going through it, it'll make it a little bit easier. And so the first thing that I want to look at is how do we find increasing and decreasing intervals? And on the graph, as you move from left to right, and you always start on the left, if you're going up, that's an increasing interval. If you're going down, that's a decreasing interval. Then here we're going up, that's an increasing interval. And how we describe them is by using the x values. And so we're going to start by identifying x coordinates of relative max and relative mins. And so what is a relative max? Right here, this is a relative max because if you zoom in, zoom in, zoom in that vicinity, that's a highest point. It's called a relative max. Same thing down here, this is a relative min because as you zoom in, at that point, it's a lowest point. So that's a relative min. And so you have relative max and mins, and then you may or may not have absolute max or mins. This would be an absolute max, and it's the y-coordinate that would be the absolute max, because it's higher than this. You could call this a relative as well as an absolute, because it is the highest point in that vicinity. So anyways, to get started, you identify the x-coordinate. So right here, the x-coordinate here is -2 of that relative max. You identify the x-coordinate, which is 3 of that relative min. And so I'm going to put a number line, and students find this helpful to do this, especially when you have to identify both positive and negative and increasing and decreasing. We identify the x-coordinates of the relative max and mins. Then that's step 1. Step 2 is determine the x-coordinate of the farthest point on the left, or if it goes to infinity. And with this arrow, it's going down, but it's also getting wider. It's going to negative infinity. So the furthest left point is negative infinity. And the next step is to identify the furthest point to the right, which in this case is at 6. So beginning and end point and x-coordinates of max and mins. So that's what those directions are. And then place those on a number line, which I already did. And now we're going to start tracing from the farthest on the left. We're going to go left to right. So from left to right, right there, that function is going up, up, up. And so that is an increasing, that is an increasing interval. And if we continue on, it's going down. So on that interval, it is decreasing. And lastly, it starts by going up, and on that interval, it is increasing. Decreasing is a little hard to see the D. There we go. And when you're doing these intervals, it's all about the x values. The x values for which y is going up, it's increasing. The x values for which y is going down, it's decreasing. But direction is important. You must be traveling from left to right to determine if it's going up or down. If you go the opposite direction, there you get the absolute opposite answer. So now we are going to include the -2 and the 3 in these intervals. And it stops at 6 and it's defined at 6, so we will actually include 6. So the increasing right here is -infinity to -2, but we're going to include it. That's different from last year. And then we have another increasing 3 to 6, and we're going to include both 3 and 6. Then you have one decreasing interval, -2 to 3, and we're going to include both of those, and that's your decreasing. When we write intervals, we always have the smallest number on the left. Let's look at the additional example because it brings in something else. The process is going to start out the same. We're going to draw a number line. And we are going to look at max and mins and beginning and ends. And so it begins, it begins to the left at -5. But we have what we call points of discontinuity. What? Here's an open hole. It's that x value is not in the domain. We can't have that in an interval for decreasing because it's not an x value in the domain. So we have to actually consider that and skip over it. And then it goes to -3. Notice we are using the x coordinates, not the heights, but the x coordinates. And so for that decrease, you go from left to right on that. And it's written over here, but I'm just going to write it down below. That decreasing, it's -5 to -4, but -4 doesn't exist, so we have to use a parenthesis. Union, -4 to -3. And we have to use parentheses because they're not x values in the domain. And you'll notice that's what's written over here for the decreasing interval. Because then we have to lift up our pencil, start here, and as we go from left to right, it continues to go up, 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 up. And so this is an absolute or minimum point, and the x-coordinate there is 1. You could also call it a relative min. But it goes on to positive infinity. And we are going, that point is a solid dot. We're going to include it. And so that increasing interval is 1 to infinity, as stated over here. So these are good notes to go back and read. There's a lot of wording there, but hopefully getting an explanation through it makes it go a little bit easier. All right, and the back, so that's increasing, decreasing. Now we change it up for positive and negative. We're still going to give x interval values for this, for the answer, but where we get the boundaries is different. So what do I mean by that? In number 1, identify the x-coordinates of any x-intercepts, the zeros. Identify the x-coordinates of any x-intercepts. So I'm going to use a number line below, and this is an x-intercept, this is, and this is. Those are 3 x-intercepts where they cross the x-axis. And we're going to put that on the number line because those are going to be boundaries for our intervals for positive and negative. And those are at -2, 3, and 8, and you have to kind of carefully count those. Notice before we used the x values of mins and max, but that's the process for increasing and decreasing. Here we're ignoring those. We use the x-intercepts. What they do have in common, though, is you have to identify the starting point, which is at -7. And the ending point here is at 10. And if we go back here and look at the notes, we've identified x, we've x-intercepts, smallest x value, largest, and placed them on a number line. So now, for 5, determine if the graph is above or below the x-axis. And so right here on this interval, it's below. And that means for those x values, this function is negative. And so it's negative on the interval from -7 to 2. For the next interval, from intercept to intercept, the function's above. And so for those x values, this function is positive. For the next interval, the function's below the x-axis, and so it is negative there. And that last little stretch it is above the x-axis, so it is positive there. Now, x-intercepts, on the x-intercepts, the y value is 0. The function is not above, it is not below. So at those points, this function is not positive, it is not negative. And so you are going to use parentheses at each of the x-intercepts because the function is not positive or negative at those. The value is 0 for y. 0 is not positive or negative. Then these other endpoints are different because at this point it exists, it's below, and so therefore you are going to include it for that negative interval. While to the right, it ends up at 10, and at 10, it's positive, but at 10, the function's not defined, it's not in the domain of the function, so we have to leave 10 as open. And some people want to stop it at 9, but if you stop it at 9, you're missing all these points at 9.5, 9.7, 9.8, 9.9, where the function's positive. So you've got to go to 10, but just leave it open. So our negative intervals, -7's included to -2, included to -2, but -2's an x-intercept, so it's a parenthesis. And then it's negative between 3 and 8. 3 and 8 are both x-intercepts, so they are open. And then it's positive on this. For which x values is it positive? -2 to 3, those are x-intercepts, parentheses are used. And then from 8 to 10, 8's an x-intercept, so it's a parenthesis. 10 is an open circle, 10's not in the domain, we have to use a parenthesis there. And there's an additional example which would be good to go through because it's a little more complex in a sense, but I'm going to leave that for you to go through because we have the other notes to continue on with. So we're going to go to common intervals of functions notes and fill these in. But that was the explanation on how to find increasing, decreasing, and positive and negative intervals. All right, so for these notes, other common intervals of functions, you are going to use interval notation with brackets and or parentheses. It varies to represent intervals, and you're representing, the intervals represent x values. And so for increase and decrease, you are increasing for any of the x values whose y values are going up. For any y values are going up. And that is as x increases, meaning you're going left to right on the graph. If you go the wrong direction, you're going to get exactly the opposite results. And so for here, we're starting from negative infinity and we're going up and up and up. And that is the relative max, which happens to be the absolute max. It's the x coordinate of that is the key boundary from where it's going to increase to decrease. So it's increasing here from negative infinity to the x coordinate of that relative max is 0. For decreasing, any x values whose y values are going down. Again, as x increases. And that means you are moving left to right on the graph. on the graph. And so that happens from this point as we go down. And again, you use the x coordinate of that relative max as the boundary. And so we decrease from 0 and it continues on to positive infinity. And there is a point where you're not increasing or decreasing, and it's the point at which the function changes direction, which is that relative max. And if your function looks like this and you're going from increasing then to decreasing, you're going to be guaranteed that you have a maximum of some type, relative maximum or absolute maximum. However, if the function decreases first and then increases, as you go from left, it's always left to right. If you're decreasing and then you go to increasing, that's going to identify a minimum of some type. A minimum of some type. You use this in AP calculus. You use this in AP calculus. You do, if you could be given a number line and you have -2, you have -3, and say it's decreasing, then it's increasing, and then it is decreasing. And say it's starting from negative infinity going to positive infinity. Well, at x equals -2, there is, and it's decreasing, so it's going down and then back up, right? Down and then back up. There is a relative min. And you write because, whatever, say this is function f. F changes from decreasing to increasing. You always name the function by its name. That is what you would write as an explanation in AP Calc to guarantee that there is a minimum there. And then you would do, and this is supposed to be increasing, and then we do the same here at x's, come on, why is it not drawing? I don't know. As x is equal to -3, lovely. And you would say that we're guaranteed a relative max because it's changing from increasing to decreasing. And it is changing, function f is changing from increasing to decreasing. So that's why this is in here. That's why we're talking about it, is because you experienced that in AP Calc. All right, positive and negative intervals are broken up by x-intercepts. And they're positive when for any x values whose y values are above the x-axis. And we use the x-intercepts. And here the x-intercepts are -3 and +3. So this function is above from negative infinity to -3. And it's above for 3 to positive infinity. It's the x values for which the function is above. And what bothers people, like it doesn't come across now in notes, is you give an answer where it's positive and you have negative values. That just blows you're not thinking about it right now because I'm showing you the process. But these are x values. And in those x values, y is above the x-axis. Y is positive. So for these x values, the function's above the x-axis. That's the interval where it's positive. So you can have negative values for positive intervals because they're the x values for where y is above the x-axis. Just mentioning that, and just be aware that can kind of throw you off as you're giving answers. But this is the way it's done. So it's negative for any x values whose y values are below. And so it's for these x values, which are -3 to 3, where the graph is below. And every y value for those values of x give you negative output. So it is negative on that interval. And where is it neither positive or negative? The x-intercepts. The x-intercepts, the y value is 0, it's not positive or negative, and that's why there's parentheses with. So you are always using parentheses on positive and negatives for all your intervals. Oh, sorry, it's not true. When it continues for a domain of infinity. If it would have stopped here, say at 4, 8, then right here we would include the 8. So, all right, so anyway, any x value whose y values are on the x-axis, aka your x-intercepts. Your x-intercepts, the function is not positive or negative. And then a quick little review of x and y intercepts. So notation y int is for y-intercept. And it has a y-coordinate on the y-axis. So right here, this is your y-intercept, and it's the ordered pair 0, 16. So the y-intercept starts with 0, because y-intercepts are when x is 0, and then you get your value of your y-intercept. And so x-int, that's how we'll abbreviate it, is for your x-intercept. And it has an x-coordinate on the x-axis. And it's right here on this graph. And that ordered pair would be 320, 0. So you have the x-intercept value, and y is always 0 for your x-intercepts. And that might seem obvious from the graph, but I can then give people equations, say, find the x-intercept, find the y-intercept, and the question is, well, how do you do that? Well, for the y-intercept, it's always when x is 0. So you have an equation, you plug in 0 for x, you get the y-intercept. For the x-intercept, you let y be 0 and solve for the x-intercept. Now that can be a little more complex because there can be many x-intercepts of a function. There will only ever be one y-intercept. And then another thing you need to be able to do is interpret your y-intercept and your x-intercept when given context. And so right here, the travel distance is your x. So this is how far you've traveled. And the y is your gas. So that y-intercept, the y-intercept of 16 is the amount of gas you start with. And gallons of gas you start with. You might be asked to interpret x and y intercepts on a CASP test. And that means, and it's also at time, that you consider 0, your starting time times 0. And then you have your x-intercept, and the 320 is how many miles you went before you ran out of gas. It's the number of miles you went when you hit a gas level of 0. Is how far you traveled. Before running out of gas. right, backside. So you're going to have a worksheet, and you're going to be given graphs, and you're going to be asked to identify all these different characteristics. And this is a parabola, and it continually gets wider and wider and wider and wider, so the domain on this is all reals. And a parabola is a polynomial, and the domain of polynomials is all reals. Now for the range, you're starting from the bottom and moving up, and that first height you hit is a negative 25. And you have to read the scale and kind of figure out the value, and that is the best value for it. And so you're going to go from there and go up, 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 up. And so that range is going to be negative 25 inclusive to positive infinity. Your x-intercepts are the values where it's hitting the x-axis, which are negative 5 and 5. Now, I am going to accept the ordered pairs negative 5, 0, and 5, 0. I'll take either of those. And it just depends on your teacher which way they want them. The x-intercepts are just the single values, but we like to see that you know they occur when y is 0, because that's you need a strong connection to that often we just like to see them as ordered pairs. And then the y-intercept is down here, and that value is negative 25, and again, I will take the ordered pair there as well. And then we get to what we were working on in class, the intervals where this is positive and negative. And you need to identify the starting x point and the ending x point. And for positive and negative, it is the x-intercepts that change for where the function's above and below. And at the x-intercepts, we use open circles because the function's not positive or negative. And for the first interval, the function's above, so we say it's positive there. On the next interval, it's below, so we say the function is negative. And on the last, it's above again, so we say that it is positive. And so it's positive on negative infinity to negative 5, union 5 to infinity. Union 5 to infinity. And it's negative 5 to 5. And again, don't get yourself confused. The interval on which it's positive, these are negative values. That's okay because the y values are positive there. These are the x values for where y is positive. So that's okay. And then for the next interval, increasing and decreasing, we identify the x farthest to the left, farthest to the right, but it is the relative max and mins, the x coordinate of the relative max and min, which in this case is 0. And then we start driving our car from left to right, and it's going down, 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 down. And so that means the function is decreasing on this interval, and it changes to going up, 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 up. And so it is increasing on that interval. By the way, this point is called you can't see it there. It's called a turning point. When it changes from decreasing to increasing. The other thing you have to be careful is you have to look at the words. This first interval, it is decreasing, and that is in the last line. So make sure that you look at the words and go, oh, yeah, so it's decreasing, negative infinity, and the 0 is going to be included. So as long as that turning point value is solid, you will include that. And then it's increasing from 0 to infinity. All right, so this next piece, you do this in AP Calc, but it's much more complex. And I'll be throwing a few of these at you here and there. And they give you all these pieces of a puzzle, and you need to draw the graph for those. And here we have an announcement.
Good morning, Hillsborough High School. Students, it's time. Once again.
Okay, I'm going to talk over him. So anyways, sorry for those listening to the videos, but here we have a domain and range for all reals. And so it's going to go forever in both directions. It's increasing on the entire interval. So from left to right, it's going up. You have an x-intercept of negative 2.5, so you can plug that in. It's not going anywhere. You have a y-intercept of 10. They're fixed. They're not going anywhere, so we can plot those. And then we have where it's positive and where it's negative, and that's at negative 2.5. Positive and negatives, you use the x-intercepts. And so it's positive from negative 2.5 to infinity, meaning the function needs to be above, and it is negative from negative infinity to negative 2.5. So sorry about that, but anyways, it is what it is. And overall, it needs to go up from left to right. So I think the best thing that explains that is just a linear, but it goes forever, so you need the arrows. Sorry about that noisy thing, but I can't help it. And then very quickly at the end here, yeah, it's a long set of notes. Relative max are here and here. In that vicinity, in those vicinities, those are the highest points. If you zoom in, zoom in, zoom in, zoom in, that's the highest point in that vicinity. But the maximum value is really the y value. So we have a maximum value of 20.372 when x is negative 4.67. And we have another max of 3.9 when x is 2.617. So these are your two relative max. And relative mins are here and here. And it's that y value, so you get a negative 4.24 when x is negative 0.674, and you get a negative 9.632 when x is 5.927. And then you have zeros, and the zeros are the same as x-intercepts. And it's just those x values, so I'm going to put them in increasing order. And these are going by twos. So it's negative 6, negative 2, 1, 4, and 7. And you could write them as ordered pairs or just list them like this, and those are your x-intercepts. So